Standard form, also called scientific notation, writes very large or very small numbers efficiently as a times 10 to the power of n. A number is in standard form when it is a times 10 to the n with a between 1 and 10 and n an integer. 3 million can be written as 3 times 10 to the power of 6, because moving the decimal point 6 places to the left gives the same value. Each jump of 1 place represents multiplying by 10, so 6 jumps means multiplying by 10 6 times. That's a million. 0.00042 can be written as 4.2 times 10 to the power of negative 4. We moved the decimal point 4 places to the right to reach the first non-zero digit, so the power is negative 4. The negative exponent simply tells us the number is smaller than 1. Each step right means dividing by 10. Move the decimal so exactly one non-zero digit sits before it, then the number of places moved becomes the power of 10. The sign of the exponent tells us whether the number is large or small. If the original number is greater than 10, the exponent is positive because we moved the decimal point to the left. But if the number is between 0 and 1, the exponent becomes negative. That means we moved the decimal to the right and the value is less than 1. 5,600 can be written as 5.6 times 10 to the power of 3. We move the decimal point 3 places to the left so that only one non-zero digit remains before it. Each shift represents dividing by 10 once, so after 3 shifts, the power becomes positive 3. 0.0072 can be written as 7.2 times 10 to the power of negative 3. This time, we move the decimal point 3 places to the right to reach the first non-zero digit. Because we had to move it to the right, the exponent becomes negative, showing that the number is smaller than 1. To change a number from standard form back to an ordinary number, multiply the coefficient by 10 to the power of n. If n is positive, shift the decimal point to the right. The number gets larger. If n is negative, shift it to the left, the number becomes smaller. 3.5 times 10 to the power of 4 equals 35,000 because a positive exponent moves the decimal 4 places to the right, making the number larger. 4.2 times 10 to the power of negative 5 equals 0.00042. Since a negative exponent moves the decimal 5 places to the left, making the number much smaller, when we multiply numbers written in standard form, we first multiply the numbers in front, called the coefficients. Then we add the powers of 10. For example, 10 to the power of 3 multiplied by 10 to the power of 4 gives 10 to the power of 7. This rule keeps calculations quick and easy. 2 times 10 cubed multiplied by 3 times 10 to the power of 4 equals 6 times 10 to the power of 7. We multiplied the numbers in front, 2 times 3 to get 6. Then we added the powers 3 and 4 to get 7. Following the rule for indices, when dividing numbers written in standard form, divide the numbers in front, which are called the coefficients. Then subtract the powers of 10. This works because dividing 10 to the power of m by 10 to the power of n is the same as 10 to the power of m minus n. 6 times 10 to the 5th divided by 2 times 10 to the 3rd equals 3 times 10 squared. Before adding or subtracting numbers in standard form, make sure the powers of 10 are the same. Rewrite one number so that both have matching exponents. Then simply add or subtract the numbers in front and keep the common power of 10. 3 times 10 to the power of 4 plus 2 times 10 to the power of 3 equals 3.2 times 10 to the power of 4. Before adding, we rewrite 2 times 10 to the 3 as 0.2 times 10 to the 4 so that both numbers have the same power of 10. Then we just add the coefficients, 3 plus 0.2, to get 3.2. 5 times 10 to the power of 6 minus 2 times 10 to the power of 5 equals 4.8 times 10 to the power of 6. Before subtracting, we rewrite 2 times 10 to the 5 as 0.2 times 10 to the 6, so that both numbers share the same power of 10. Then we subtract the coefficients, 5 minus 0.2, to get 4.8. If the coefficient goes outside the range from 1 to 10 after a calculation, we need to renormalize it. To do that, shift one power of 10 between the coefficient and the exponent until the coefficient is back between 1 and 10. For example, 20 times 10 to the power of 4 becomes 2 times 10 to the power of 5. When a number in standard form is negative, the minus sign is attached to the coefficient, not the power of 10. For example, minus 0.0032 can be written as minus 3.2 times 10 to the power of negative 3. The minus sign only tells us the value is below 0. It doesn't change the size or direction of the exponent. When comparing numbers in standard form, focus on the power of 10 first. The larger the power, the larger the number. For example, 6.9 times 10 to the power of 6 is bigger than 7.1 times 10 to the power of 5, even though the coefficient is smaller. 6.9 times 10 to the 6th is larger because the power of 10 is greater, even though the coefficient is slightly smaller. A typical science context. The Earth-Sun distance is about 1.496 times 10 to the 8th kilometers. On calculators, use the EXP or double E key to enter powers of 10 safely. If your coefficient is not between 1 and 10, fix it by renormalizing the power. Never add or subtract standard form numbers without first matching the powers. Estimate first to catch place value slips and sign errors. Master conversions both ways: multiplication and division rules, addition and subtraction by matching exponents, and renormalizing the coefficient. Now practice with the interactive questions on RecoStudy to lock in your skills.